We're going to find the inverse of a quadratic function and then graph both the function and its inverse. So first of all, let's go back and remember how to do that from the last couple of videos. What you'll do is you'll set y equal to f of x, and f of x is x squared, so I'm going to say y equals x squared. And then you want to swap your x and y. So put the x here and then the y there, and then you want to solve for y. So we'll take the square root of both sides, and y will equal we only really want to use the positive square root of x because right up here when I gave you the function, I told you there was a limitation or a restriction of x having to be greater than or equal to 0, so meaning the positive numbers. We're only looking for this side from this x equals 0 over to the positive numbers. So now I'm going to replace this y and actually instead of calling it f of x, since it's the inverse, I'm going to call it g of x. So the g of x equals the square root of x. I want to graph both. Now hopefully you remember how to graph x of squared. You put a point on 0, 0. You go right 1 and up 1 and put a point. Then you go right 1 and up 3 and put a point. But just in case you forgot that and how I got all those numbers, it's just like choosing 0, 1, 2, 3 as my x's and then plugging them into the problem. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So the only one I didn't graph just by memory was the 3, 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, with the restriction that the x's have to be greater than 0, I'm only doing this side right here of this parabola. Okay, now we just got through graphing the square root of x many times on the last couple of problems, but just in case you don't remember how those came about, we're going to choose the numbers 0, 1, 4, and 9 since those are perfect squares. And the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So I have a point here and here. And then I'm going to go 1, 2, 3, 4, 1, 2 and put a point. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 and put a point at 9, 3. And this is what that parent graph of a square root looks like. So we're calling this one g of x, and we call this one f of x. So there's the function, and there's its inverse.